Hello, this is Nick Glorioso for the Embedded Systems Homework 5, 6, the interrupt button. Right now it's just going ahead and flashing, and while it's doing that I'll explain this briefly. We just have the button coming in from pin 4, and then it has a resistor on the input side, so the pin uses a pull-up resistor, so this will pull down and then it's connected to ground. And then I decided to just go with 6 LEDs because I wanted to see them count more, and it's very easy to add them with these drivers. And so those guys are just like all of the pins from 10 to 21, or 22. Sorry, I don't have 21 in here. But yeah, like 10, 5, 18, 23, 19, 22 are the pins for the outputs. But as you can see, the timer is going, which the structure of the code is basically just the GP timer example and the GP, or generic GPIO, basically just combined together. The generic GPIO is basically just in this little config GPIO function, which is just all of the stuff from generic GPIO minus the stuff that I didn't need, since I only have like one input and I wanted it to be negative edge controlled. Otherwise, the rest of the main function, I guess, is all of the timer things, which I would have put into a little sub-function like the GPIO, but I couldn't get it to work, and I think that's because of this little queue element, because technically I defined 2 queues, but every time I tried to combine the queues, it really wasn't happy. So I just went with this, and it's working pretty good. Otherwise, in the main, basically we have the, this is for the timer alarm, which again, I feel like I should have been able to add to a queue, but it just wouldn't with the methods I tried, so it's sitting here in the while loop. And then this is control for basically the button debouncing, because basically within the task example, what happens is it'll detect the interrupt. If it's 0, then it'll count. The interrupt flag basically just makes sure that we don't get multiple interrupts, because it comes into the interrupt. If it's 0, it counts, changes all of the LEDs, sets their level, and then it disables the interrupt until the main while function re-enables it. And this seems to work pretty well for debouncing. So I don't know if you can hear, but that's just one button push, and I can, here, it's a little easier here. And I can count pretty quickly with it. And it'll update pretty quickly. The one weird behavior that I wasn't able to figure out is that, because it should be set to a negative edge trigger, and since it's from a pull-up resistor, it should only trigger at the very beginning of a button push, but for some reason when I push and hold, it goes straight through, and I don't know why pushing and holding does that. Theoretically, with the way I coded it, it shouldn't, considering I take the negative edge and then debounce that signal and do the things. But it does. But here's just the actual function counting. Basically just every time the button is pressed, it'll say that and then indicate what the count is. And as I said before, the count is automatically transferred to the LEDs, or the LED level is set every time count is incremented by the interrupt function, the interrupt task function. Otherwise, I think that's most of what I changed, because most of this is just the GPIO, or GP timer and generic GPIO. Otherwise, up here I just changed to one input, and here I added a few more inputs and defined their pins. And then here are just some general global variables for the count and the interrupt flag and whatnot. And yeah.